Hello. Today we're going to start graphing exponential functions based off of all of the transformations that we talked about yesterday with our Desmos activity. First, though, we want to talk about an asymptote. So an asymptote is going to be a line that the graph approaches but never touches. A line that the graph approaches but never touches. So when we were doing all of our graphing activities, all of our graphs look like this. There was actually a horizontal line that you can't see on the graph, but the graph here is approaching it as you go to the left or to the right for forever, but it never is going to actually touch. That is your asymptote. So every exponential function has an asymptote, and we'll talk about where that will be based off of the transformations. So as a recap of that Desmos activity, A is going to do a couple of things. If A is bigger than 1, that is going to stretch the graph vertically. If A is a fraction, so for instance, if it's like 1/2 times 2 to the x, if it's a fraction in between 0 and 1, that's going to compress the graph vertically. And if A is negative, so if out in front you have a negative, that is going to be reflect over the x-axis. H is up with the x, it has to be the exponent. So H is going to move the graph left or right. And it's going to be left if it's like x plus a number. It's again doing the opposite of what you think. It's going to be right if it's x minus a number. Well, and then your next one, your k value. K is at the end. That's going to move your graph up and down. So it's going to be up if it's plus a number. If it's going to be minus a number, that's going to move it down. All of these graphs are going to have asymptotes because your graph is either going to be a growth function or a decay function, but they're all going to have horizontal asymptotes. So since it's going to be a horizontal asymptote, it's always going to be y equals a number. And the number it's going to correspond with is going to be your k value. It's your vertical shift up and down. So whatever you're moving up and down, you're going to write y equals that number, and that's your asymptote. Because your graph has that asymptote, that's going to change the range of your graph. The range of your graph goes from low to high. So if your graph does not reflect over the x-axis, the range is going to start at k and it's going to go up to positive infinity for forever. K is going to be interesting because it's going to have a parentheses, not a bracket, because it is an asymptote and it never actually touches that value. If your graph gets reflected down over the x-axis, then your range is going to be different. It's going to start down at negative infinity, and then it's going to get really close to your asymptote but never touch it on that end. So your range depends on your graph. For your exponential functions, your domain is always going to be negative infinity to positive infinity because you can take any number and you can plug it in and get something out. So there's no restrictions on your domain. The other important thing to remember about exponential functions is it's going to be a growth function if your base is greater than 1. So if you have, for instance, y equals 1/2 times 3 to the x, your base is going to be the important one. So if your base is bigger than 1, it's a growth function, and it's going to look like this initially. And if your base is a fraction, it is going to be a decay function if that fraction is in between 0 and 1, and it's going to start high and it's going to decrease from left to right. So all of this together is going to impact the graph. So all of this is going to be compiled. That's going to be interesting. So let's go ahead and look at an example here. The first thing we want to do when looking at this is to identify A, H, and K and the base. So A is normally out in front here. Since there's nothing there, A is going to be 1, which means there's no vertical stretch and there's no reflection over the x-axis. Your h value has to be up with the exponent. So right here you see x plus 3. That's going to move your graph left 3, which means we're going to write minus 3. H is going to always be the opposite of what you see there. Your k value is at the end there. It's going to be minus 5. It is moving your graph down 5. And your base is going to be extremely important for this. So it's important to be able to look at the bases 2 because that's what's being raised to the power. So what we're going to do to fill out the table then is we're going to fill out these values for your x values, but do them off to the side. So -1, 0, and 1. Those are going to be your initial x moved all around. So you're always to the side. Your y value depend on the base. This is we're going to do the reciprocal of the base. We're going to do 1, and we're going to do whatever the base is. This comes from plugging in -1, 0, and 1 as your exponents, but this is what you would get out. So for our first one, we're going to do 1 divided by our base, so that becomes 1/2. The next one is always going to be 1, and then the next one is always going to be whatever that base is. So for this one, our base is 2. So these are things that you're just going to have to remember. These are x values that are normally nice to plug in, and normally you would get 1/2, 1 and 2 back out, or 1 over your base, 1 and your base. And so now what we're going to do is we're going to take, and if nothing was transformed, these would be the points that we would graph, and this would be how we actually get our graph. But we are moving things around. So to move things around, to your x values, you're going to add h. H always goes with your x values. Your a and your k are always going to affect your y values. So you're going to take your y values and you're going to multiply by a, and then you're going to add k to them. So every single time you do a graph, your h value is going to go with your x. Your y values, you're going to multiply by a and then add k. So let's see what this looks like for this problem. So for this one, my h was -3, so I'm going to take each of my x values and I'm going to subtract 3. If you're a visual person, we're doing -1 minus 3. When we get our answer to that, that's going to be our new x value. So we're going to do 0 minus 3 and 1 minus 3. These are our new x values. They're going to be the ones that we want to actually graph. For your y values here, what we're going to do is we're going to take our y values and we're going to, in this case, multiply by 1 because our a value was 1. And then after we do that, we're going to add k. So we're actually, it's not even a positive 5. We're going to add or subtract actually 5 from these. So we're going to do 1/2 times 1 minus 5. And when we do that, we can use decimals, we can use fractions. That's going to be -4.5. That is our new y value, -4.5. And so we're going to take our next value. We're going to do 1. We're going to multiply it by 1 and subtract 5. We're multiplying by a and subtracting k. So 1 times 1 minus 5 is -4. That's our new y value. And then our next one, we're going to do 2 times 1 minus 5. When we figure out what that equals, that's -3. That's our new y value. And so this part in the table here, this is what we're actually going to graph, those new points, because we have now moved them left 3, we have stretched them by 1 and moved them down 5. So -4 comma -4.5 is about here, -3 comma -4, and -2 comma -3. This is going to look like that exponential function, so that kind of slide looking graph. So to help graph a little bit more accurately, we're going to graph our asymptote. So it's going to be y equals your k value. So for this one, it's going to be y equals -5. And we're going to draw a dotted line for our asymptote to show us that the graph is supposed to get really close to that, but never touch that. So it's getting close to that, but never touching that. After we have that line in there, we can go ahead and connect this, trying to make it look like the exponential function we know it should be. For our domain then, from left to right, it's going to be -infinity to +infinity. All exponential functions are going to be that. Your range is low to high. So for this one, our graph starts down here at -5, but it never touches it because it's an asymptote, so it's a parentheses. And then it's pointing up for forever, so that is a positive infinity. Your growth or decay is based off of the base. So for this one, the base is 2, it's going to be a growth function. And to describe the transformations, we actually already kind of did that at the beginning of the problem. This is moved left by 3 and down 5. And now we can kind of visually see that it does look like it's moved left 3 and down 5. Looking at this one, our A value is -3. It's out in front. Your H value is going to be the opposite of there, what's up with your exponent, so it's +4. And your K value is being added at the end, so it's +2. Your base for this one is going to be 2/5. So for my x values, what I'm going to do is I'm going to write -1, 0, and 1. Those are always going to be my x values. My y values are the reciprocal of the base, 1, and the base. So our base for this one is 2/5. So that's going to be that last one. 1 is always going to be 1. And the reciprocal of the base for this one, if we have 1 over 2/5, we don't like looking like that. So we're going to multiply by the reciprocal, which is going to end up flipping our fraction. So 1 over 2/5 ends up being 5/2. So you can always just flip. Now what we're going to do is values. These ones are going to add 4 to each of them. Add 4, we get 3, 4, and 5. For your y values, you are going to multiply by -3 and then add 2. You're always going to multiply by a and then add k. So for this first one, we're going to do 5/2 times -3 and then add 2. And so what we can do is we can type that in and get -5.5 on our calculators. For the next one, times -3 and then add 2. We get -1 back out. And the last one, we're going to multiply again by a, which is -3, and add 2, and we're going to get 0.8. So we're going to graph each of these, 3, -5.5, 4, -1, and 5, 0.8. We're going to graph our asymptote, which is going to be y equals 2. That's the line that our graph should get close to but never touch, and we can actually go ahead and connect all of those. Your domain is -infinity to +infinity. Your range is low to high, so this starts down at -infinity and goes up to our asymptote. Normally for this one we would say decay, but since your A value is negative, it's actually going to be neither. So anytime A is negative, you're going to say it's neither growth nor decay, because it's supposed to go down for forever, but it's not really looking like it is. Our transformations involve the reflections over x, the vertical stretch, and moving right 4 and up 2.